Hi, I'm Bob Wormsley, and this is part 2 of our Cinema 4D Wispy Smoke tutorial. And in this part, we're going to be taking our Xparticles simulation and we're going to be multiplying the amount of particles massively using the brilliant particle plugin renderer Krakatoa. So let's jump into Cinema 4D and we can start building and rendering this fantastic, realistic, wispy smoke look. So here we are back in Cinema 4D, and this is where we last left the project from tutorial 1. So if you've not got to this point, click on the box, go and watch tutorial 1, get it saved, and you'll get to this point. So what we have are a couple of things here. We have a Turbulence FD container, which contains the cached simulation of our wispy smoke going up like this. And there it is. And this is cached, so it's not having to draw it on every frame, which means we can scrub backwards and forwards. So this is what we use to drive our Xparticles. So we've got our Xparticles emitter, and it has a red cache tag, which means it's reading it from the cache, and that is being pushed by the fluid from Turbulence FD. So I'll just switch, make it invisible, Turbulence FD. So this is it. This is our fluid simulation, and we can see that the particles are being pushed around nicely. Let's zoom in a little bit. There we go. And if we put it to this point and we press render, we've got this wispy smoke look. And it looks good, and we can animate there and we can render it from there. The problem is that we don't really have enough particles for this to look smooth and milky like smoke should. We can see it's very speckly and very dotty. Now what we could do is we could up the particles being emitted by a lot more. So at the moment it's on 100,000 particles per second, and it's emitting for 75 frames. So it's about 300,000 particles this, and it's nowhere near enough. I would say we need 10 times that for it to start looking milky like proper smoke would. So if we bump this up to, say, 1 million per second, it would start grinding to a halt. Xparticles kind of has its limitations at around that much. You can, on paper, do it, but it goes very, very slowly, and it uses all of the RAM in your system, and it can kind of freeze up, and it's not a good idea in my experience. So what we need to do is we need to be able to increase these particles. And the way we're going to do that, we're going to use a different plugin now. We're going to use Krakatoa, which is a particle renderer. So where we find Krakatoa is in our plugins menu, and we have Krakatoa, and we have this list of Krakatoa objects. So that is most of the stuff that we will need. But then what we need to do is also look in our render settings, and we need to select in our renderer Krakatoa as the renderer we're going to use. So as soon as we select that, we can just deselect Xparticles and Turbulence. Now under Krakatoa, we've got all of these different Krakatoa settings, which at first look incredibly confusing and complex, and they take a bit of getting your head around. Fortunately, we only need to use very few of these settings for our smoke sim. So let's go back to the viewer. So the first thing we need to do is we need Krakatoa to be able to see these Xparticles. And the way we do that, we go to Plugins, Krakatoa, and we need to bring in what's called an Xparticles source. So let's click on that, and here it is. And it's very clever, Krakatoa. We've brought this in, and it's already recognized that we have an emitter in our scene, and it has put the emitter inside this Xparticles source. So now, if I just move it to here and press render, it's rendered. But it hasn't rendered using Xparticles because, look, we've got the Xparticles renderer switched off. This is Krakatoa rendering these particles. All right, but it looks very similar. It's still far too speckly, so we need to sort this out. So what we are going to do is something that is quite clever, but like rendering, it takes quite a long time. What Krakatoa is going to do, it's going to run this Xparticles simulation from start to finish, and we're going to set it to run, say, 30 times. And each time it's going to give a different random seed right at the beginning of the simulation. So the particles are going to be born in a slightly different position for every run through. And that means that when all those run throughs are laid on top of each other, it will create a particle cloud which is 30 times more dense. It's got 30 times more particles. So I'll just do a little demonstration to explain what I mean by that. So what I'll do is, let's just disable the cache, go to frame 1, and I'm going to move into this Xparticles emitter. And what I'm going to do is I'm going to duplicate it, and then I'm going to duplicate it again. So now we have 2 new emitters. This first one I'm going to disable because we don't want to look at that. And this first emitter, I'm going to set its birth rate to shot, 1 frame, duration 2, and I'm going to say just make 10 particles, and I'll just switch that third one off for now. Okay, so, and let's just switch off the Turbulence FD Sim, so they're going to be stationary, and we'll make them squares. Okay, sorry about that. Here we go. So Bosch 10 particles which have appeared here. Now they've appeared randomly. How have they appeared randomly? Well, if we look in the advanced tab of our emitter, we have a random seed. So let's just, I'll tell you what, I'll delete that one and we'll duplicate this new one, put it there. And this new one, let's give it a different seed. I'll just pull that down, there we go. So now let's press play. Now, they've both produced 10 particles randomly, but look, they're in a different position because we changed the random seed of this one. And that is what Krakatoa is going to do. It's going to run through this simulation. We're going to set it to do 30 partitions, 30 takes. And at the beginning of each one, it's going to change the random seed. So each take will have a different start position, which means they'll be pushed around by the fluid slightly differently. Okay, so that is the principle. So let's get rid of those 2 new ones. Activate that. Turn Turbulence FD back on. Right. And activate our Xparticles source. And we need to make sure that the cache is switched off. It won't work if you're using the Xparticles cache. Right, so now we need to set Krakatoa to save all of these new partitions. How do we do that? Well, we do it like this. We go to our render settings and we go to Krakatoa and we are going to go to the output. And the output, instead of rendering to viewer, we want to save particles to a file sequence. And we'll leave that as it is. We'll bring this down. And here we have a partitioning section. So we're going to say save multiple partitions and we're going to make 30 partitions. And we're going to have increment emission random seed selected. So that basically is going to do what I've just demonstrated. It's going to give a different random seed for each partition. Okay. So that's okay for now. Then we're going to go to the output and to the save tab to tell it where to save this to. And we use just the regular Cinema 4D save area. So I'm going to go to File and we'll go to the Cache folder, Tutorials, and I'm going to make a new folder and call it Crack Smoke Partition. And we're going to go in there and we're going to call it, let's call it Crack Smoke Partition. So that's going to be the file sequence. It's going to be called that. Save. Excellent. So that's all we have to do for now. Now we need to save the frame range as we always would. So we'll do manual 0 to 300 because that's when the simulation runs out of particles. So there's no point in simming a lot more. Good. So then let's go back to our Krakatoa box. And we need to go down to this button. So we're saving a particle file to sequence. We're going to run it 30 times, 30 partitions, which we're going to layer on top of each other. And we are going to now hit Submit Saving Job or Partitioning Jobs. And what this will do is open the batch rendering window in Cinema 4D. So let's just have a quick go. So click Submit. And here we have got our render queue. And I'll just make this a bit bigger in your screen actually so we can see exactly what's happened. So it's queued up all of these different partitions. So partition 1, 2, 3, 4, all the way down to partition 30. And if we just click on the one that's in progress, we can see here how quickly it's running through. So it's at 68, 69, 70 frames. So this isn't a quick process. We have got to run through this 30 times, and it's going to take, I'm imagining, about 3 minutes per go. So it's 30 times 3 minutes. So it's going to be an hour and a half to get all of this. So I'll pause the tutorial here, and then we'll rejoin me when it's complete. I'll tell you how long it took, and then we'll go to the next stage. Okay, welcome back. So we have rendered all of those partitions. We've got 30. I'm just going to open up the folder in my Explorer here and show you. So this is the particles folder to which we saved these partitions. You can see here are the file sequences, and this is what they're called. So crack partition 1 of 30, 00, and there's a frame, a clip sequence. So there's part 1, part 2 of 30, part 3 of 30, part 4, and it goes all the way down to 30. So we have saved these PRT particle files, and we've got 30 now from one Xparticles simulation. So how do we then open that in the viewer? Well, the best thing to do is to actually start a new project, because even if you disable all of these, because we don't need them anymore, for some reason your scene will run really slowly, and I'm not sure, but one of these bits of software plugins is reading the cache, and even though you disable it, it carries on trying to read it, and I haven't worked out which. So I think the easiest thing to do is, we don't need any of this now. We're going to start from scratch with our new PRT partition sequence. So let's just go to new project. I'm working on 25 frames per second, but you can do whatever you like. Going to go to my render settings and change that to 25 as well, just to make sure that we're all okay. And I'm going to give myself 300 frames in the viewer. Good. So now we need a Krakatoa object that can read those new files that we made. So I'm going to go to Plugins, Krakatoa, and we want a Krakatoa PRT loader. So I'll click that. And now what we need to do is tell it, what do you want me to read? Where is the particle file? So I'm going to browse here, look for my folder, Krakatoa partitions, part 1 of 30. So just select the first. In fact, I think you can select any of these sequences and it'll recognize it as one massive sequence. So I'll press open. So here it is. And if I scrub through, there we've got the particles. If I zoom in, this looks exactly the same as the Xparticles one. There's no more particles there. So what's going on? Well, what we have to do is tell it to use all of those 30 partitions. At the moment, it's just reading one. So, of course, it's exactly the same as the Xparticles sequence. So we go across here to our PRT loader settings, make sure sequence is selected, and then we're going to say load additional partitions. Click that. And if you see this grayed out value, it's saying partitions found 30. And it's only loaded one of those 30. So I'm just going to zoom in a little bit. So this is the magic of partitions. So this is the same as the Xparticles render. And if I start increasing these partitions, you can see that we're getting more and more particles in this frame. So I'm going to put that to 30. Let's load all of them. And let's go now. So now we've got loads of particles. We are ready for a render. So let's go to our Krakatoa renderer. Let's go to our Krakatoa settings, and the output we want set to the viewer. Okay, good. So now we're ready to start the rendering process. So we'll press render. Now this is going to take a wee while because we have an awful lot of particles and it looks absolutely dreadful. What have we done? Well, this is because at the moment not enough light is passing through these particles for it to look detailed. It's looking like this big, horrible, blobby mess. So this is the only other slider that we're really going to mess around with in Krakatoa, is setting the density of the particles, how much light can pass through them. So to do that, we're going to go to our Options tab, and we're going to ignore absolutely everything in here, apart from lighting and drawing pass. So let's swirl that down. And again, we're going to keep everything default, and we're just going to concentrate on this value here, final pass density with this exponent value. So this is an absolute nightmare. Unless you are kind of mathematically minded, these two numbers won't make any sense to you. What these two numbers do together, they give you a value of between 0 for no density at all and 1 for 100% density. And you get those values of between 0 and 1 by having different numbers in both of these. How do you do that? Well, we need to know what they mean. And this, I've got to tell you, this took me a long time to get my head around and to work out. I'm going to try and break it down for you. How we use these two numbers to give you a value between 0 and 1. Why they didn't just put a little equals box and tell you what number you've got is absolutely beyond me. But here it is. Here's my interpretation of it. So I need my calculator, good old Windows calculator. There's one on a Mac as well. And you need it in scientific view. And I'm going to just open a Photoshop file here so I can draw on it. So here is what we do. This value at the moment is 5 and minus 1. What number does that give us? And what do these mean? Well, what it means is 5 times 10 to the power of minus 1. That's what these two numbers mean. So let's do that on the calculator. Let's do 5 times 10 to the power of minus 1 equals 0.5. So let's write that down in our little notepad. 0.5. So this default value is giving you a number of 0.5. So it's kind of 50% density. So let's just try another one. Let's just reduce this exponent to, let's say, minus 3. So what number, I'll just do a quick render. So we've changed the exponent. We've changed the density. Let's do a quick render. All right. So that's looking different. Let's have a look at what this number means. 5 times 10 to the power of minus 3. So let's just get our Photoshop and our calculator up. Here we go. 5 times 10 to the power of minus 3 equals 0.005. All right, so let's write that down. So 5 times 10 to the power of minus 3 equals 0.005. So this is how it works. The first number gives you what number will be in your value between 0 and 10. And the second number tells you how many decimal places it will be. So this one, the number is going to be 5 with 3 decimal places. So here is the dot, decimal place 1, decimal place 2, decimal place 3, and it's a 5 because we've put 5 here. So that's how you use this scale. So I'll just demonstrate another quick one just so you've got your head around it. So this number is obviously an awful lot smaller than this number. Let's put a 9 in here, and let's put a -5 in this number. We'll just try rendering, just so you get an idea of what that looks like. Okay, so now we're getting there. So this has a much lower density value because more light is able to pass through those particles. And let's just have a look at what this means in our little maths lesson here. And we need our Photoshop file as well. So what have we got? So we've got 9 times 10 to the power of -5. So what that means is it's going to be 5 decimal places. 1, 2, 3, 4. And then the 5th decimal place is going to be our number, which is 9. That's what I'm guessing this is going to be. So let's try it on the calculator. 9 times 10 to the power of I've done that wrong. Balls. Let's try it again. 9 times 10 to the power of 5 minus equals 0.00009. Yes. Okay. So that is a very long way round of explaining that this number only can give you a value between 0 and 1, but it gives you an awful lot of control, doesn't it? Because you can go to so many different decimal places. And this value for our render is looking pretty good. We need a very low value, and that is looking really detailed and really, really wispy. Okay. There we go. And I think very, very quickly we've got a decent value. So let's just move this back a little bit. Let's see what it looks like lower down in the render with this density value. That's okay. Perhaps a little bit bright, which means that it's got too much density, which means we could lower it even more. So I think, yeah, I'm going to lower that even more. So here's what I can do. I can lower this one, but I think if I go to -6, it's adding another decimal place. So it's going to have lowered a huge amount. Let's have a look. It's probably too much. Yeah, so we've gone too far. All right, so let's keep it 5 decimal places, but we'll lower the number. Let's go down to 2. So the more you play around with it, the more you'll get your head around how that density value works. But here we go. So that's looking quite nice now, I think. I'll just scrub forward to nearer the end just to make sure that it's going to look okay nearer the end of our render. So perhaps I've gone a little bit too much there because we've lost detail here. It's almost disappeared. So yeah, let's just try slightly higher value. Let's go with 6. So 0.00006. Looking good. Excellent. Okay, so let's just try a render now. So what we're going to do is we are going to not save. I'm going to output manual 0 to 300 frames. Just going to click alpha channel, and we're going to render to picture viewer and see how this looks. So let's render. So what you can do, if you want to have a look at how many particles it is drawing, and you can see it's still going pretty quickly through this render, you can go to Script Console, which brings up the console here, and this is telling you how many particles it's rendering per frame. So we're on 3 million at this point, because it's okay. And here's the particle amount. Sorry, it's moving up because it's doing it frame by frame. But here's the particle: 4 million, 4,200,000, 4,300,000, and you can see how many particles you're getting on every frame. So obviously, the more particles that appear in the scene, the longer this rendering process is going to take. But if you think that it's rendering already 5 million particles per frame in 1 second, that is pretty impressive. So we'll leave that going, and I'll pause the tutorial for now, and I'll come back to you once this render's finished. Hi, welcome back. So that's finished rendering, so we can play that sim. Let's load it up into the cache. And as you can see, we have so much more detail now with our close to 30 million particles that Krakatoa rendered. We've got this beautiful wispiness. And you can have a look here at these render times for these frames. And the most it ever took was 2 seconds for a frame. 3, I think there was 3, a few for 3 seconds. So that's incredible, really, that it's rendering almost 30 million particles in 3 seconds. Now, I have a relatively powerful workstation. This is a 16-core, 32-thread Intel workstation with 64 gig of RAM. So it is powerful, but even if you're working on a home workstation or an iMac or something like that, you're still going to get fast results with Krakatoa. Now, we've hardly scratched the surface with Krakatoa and this tutorial. We have just looked at the basics of loading up a PRT sequence using this PRT loader. We've looked at creating lots of partitions of the same Xparticles Sim, and we layer those on top of each other to get this much more detailed and high resolution sim. And we've looked at some of the basic Krakatoa render settings, this final pass density value, which gives you a value between 0 and 1, which tells Krakatoa the density of these, with 1 being completely dense density, so no light can pass through, and 0 having no density at all, so they would be invisible because the light would pass straight through them. And at the end, we get this nice sim. We haven't looked at using motion blur, which we can do with Krakatoa. We can also render with depth of field, and we do lots and lots of great effects. Now, I would say to you that from this camera angle, this sim is just about high resolution enough. But if you look here, I'm just going to zoom in a little bit. It's still a bit too speckly. Around this section, we're seeing kind of individual particles here, and that is telling me that there still isn't enough resolution for this to be a really milky sim. And if we were zooming in close and having the smoke almost blowing over the camera, we would need yet more particles. So we have almost 30 million particles. If we want to get really in close to this, I would say you need probably closer to 100 million particles. So that would mean going back to the Xparticles and running it 100 times in 100 partitions to layer up, and that would give you much more milkiness. But for now, for this tutorial, I think this is looking really, really nice. We're getting lovely wisps, nice detail, developing really nicely, and then beautifully fading out into nothing at the end. Okay, so that's the end of this part 2 tutorial. Please, if you liked it, if you could comment below, that would be great. And if you could subscribe to me, if you haven't already, that would be fantastic. And then you will get in your inbox whenever I've got some new particles, some new tutorials lined up. And there's going to be loads more that I'll be making, looking at different camera animation and doing bullet time and freeze framing and all kinds of cool stuff using these plugins. So until next time, see ya.